In this video, I would like to do a couple of examples of applications using the law of cosines. So the first one I have already written out and partially drawn because it's a little bit of a difficult drawing. So if you need to pause the video to copy it, you can. It says that two airplanes leave an airport at the same time on different runways. Obviously, they're at the same airport though, so approximately the same location to start with. One flies on a bearing of north 66 degrees west at 325 miles per hour. The other flies in a bearing of south 26 degrees west at 300 miles per hour. And our question is, how far apart are the airplanes after 2 hours? So the first thing I did is I started with the bearings. I haven't completed the drawing yet. So remember, for our bearings, it's always off a north-south line. So I just drew a little dot here for the airport. Now, even though they're on different runways, the planes would be relatively close to one another when we're talking in, such large distances for miles here. So I'm just doing a dot for the airport. So they'd be leaving from the same location. Now, the first one is going northwest. So, we're going towards the north direction, west. So we're off the north side of that north-south line at 66 degrees. And then the other airplane is going south. So again, off the south side of that line, also going west, so going towards that left there at 26 degrees. Now, if 2 hours have passed, well, that first plane is traveling 325 miles per hour. So after 2 hours, 325 is how far it travels in 1 hour. So if you multiply that by 2, you get 650. So this distance here, again, I'm just using a little arrow to show the airplane, is 650 miles. On the other end, that airplane is going 300 miles per hour. And again, it's for 1 hour. So for 2 hours, we multiply that by 2, and we see that, the airplane over here is at 600 miles. Again, this is not to scale, so just keep that in mind. So at the end of 2 hours, this airplane is way out here. And at the end of 2 hours, this airplane is now way out here. And our question is, how far apart are they? So we're actually looking for this length between them right here. So that's going to be our starting piece here to get us going. So hopefully that picture is relatively clear for you. And again, if you need to, pause this video and go ahead and copy it down. So now when you're ready, we need to start to solve. So we do need to figure out this right here. You can call it whatever you want. I'm going to call this point A for airport just to make it easier. So I'm looking actually for side A in this case. And there's one more piece of information I do have. I do have these angles here. Notice that when you're along the north-south line, right? So this whole angle is 180 degrees, right? Because it's a vertical or a horizontal line. That's always 180 degrees. So I know the first part is 66. I know the bottom part is 26. So I'm able to find that missing piece here. I can take that 180 degrees, subtract 66, and subtract 26. And what I get is 88. So I actually can find the angle here of this piece. And that is 88. Oops, does not look like 88. That is 88 degrees. So I do need to find a little bit more information before I start. All right, so now look about what triangle I have. I have a side, I have the angle in between, and I have another side. So I actually have a side angle, side triangle in this case, right? Here's my side, here's my angle, here's my side. So you can go back to your steps. Okay, well, what do I do when I'm dealing with a side angle, side triangle? And the first step is typically to find the missing side. And that's actually what we need here. So it works out perfectly. So what I can do is I can use the law of cosines. To go ahead and find the missing side. I'm going to use A here, so I'm just kind of calling things A. We can call this one B and this one C, if that is helpful. So my formula is going to be A squared is equal to B squared plus C squared minus 2BC cosine of A. And again, I'm using the one that I'm trying to find. So I'm using that version. All right, so my B would be the 600. My C would be the 650. And my angle here is 88 degrees. Now you can just use your calculator here for everything. Cosine 88 degrees is not one that I would know. These numbers are huge. So again, I would just use my calculator and take my time plugging this all in. And you can try it at home. You should get that A squared is about 755,278. So around 755,278 here. Again, we are rounding. And then what you could do is you can take the square root of both sides. And when we do that, we get that A is about 869. Again, rounded to the nearest whole in this particular case. Now our units were in miles. So the planes be about 869 miles apart after 2 hours. So there's one more thing I want to talk about in this video, and that is area again. And that is Heron's formula for an area of a triangle. You can derive it using the law of cosine, so I'm not going to do the derivation here, but that's how it applies to this section. So it says that the area of a triangle with sides A, B, and C is S times S minus A multiplied by S minus B multiplied by S minus C, and then take the square root of that, where S is equal to 1/2 A plus B plus C. So 1/2 the perimeter of the triangle. So just another interesting formula. And it's one where you actually, again, don't need that height. So you don't need to have a 90-degree angle to actually use this formula here. So we're going to find the area of a triangle with A equals 12 yards, B is equal to 16 yards, and C equals 20 yards. And again, we're going to use Heron's formula here instead. So the first thing I would like to find is S. That's used so frequently. I don't want to have to, rewrite this expanded formula all the time. So it's 1/2. A is 12, B is 16, and C is 24. And you would go ahead and add those all up, and then you would take half of it. And in this case, you actually get a perfect 26, which is nice. And of course, you're just using your calculator there. So then my formula S is 26. So it'd be 26 multiplied by 26 minus whatever A is, which is 12. And then 26 minus whatever B is, which is 16. And then 26 minus whatever C is, which is 24. So this becomes 26. And then 26 minus 12 is going to be, 14. 26 minus 16 is going to be 10. And then 26 minus 24 is going to be 2. So you're going to go ahead and just take the square root and multiply all those values together. Make sure when you're taking the square root, everything stays under the square root there. Okay, so here's my square root. And then I have 26 times 14, 10, and 2. Notice how all those numbers are still under the square root. And then I hit enter. If your calculator doesn't do that, you can put them in parentheses to make sure they all stay under the root, or do the multiplication first. Right, and then take the square root of that value. That is another way that you can do it and get the same result. So just be careful there, make sure that multiplication stays under the root. So you end up with the square root of exactly 7280, which is about 85.3. If we round to the nearest whole, so this is about 85. Again, this is yards squared, or 85 square yards. You can write it that way too. So just don't forget for area, you're squaring your units there, and that's why you have that change. So another helpful formula, I think this one can be really easy to use, particularly, you know, if your numbers come out nice, even if they're odd, I mean, you're dividing by 2, so it's not going to be that bad of a decimal. So this is a really nice formula just to have on hand, and you don't have to use sine and cosine all the time, which is helpful.